Yesterday we were solving when we were given the story problem. So we had to draw the triangle and we had to find the trig function, and then we used the inverse to solve. Okay, today we are still going to be using the inverse trig function, and we're going to be solving for values of theta on the unit circle that are not exact values. So earlier we would find like the sine of, when is the sine of theta 1/2? And the sine is 1/2 at pi over 6, okay? That's an exact value, but it's not always going to be at one of those special places on the unit circle. So we can solve even if it's not an exact value by using our calculator. So we've talked a lot about the exact values, that pi over 6, pi over 4, pi over 3, but there are an infinite amount of points on the unit circle. And so we're going to use our calculator to help solve some of these cases. And we're going to keep this in degree mode. Okay, when you go up to pre-calculus or trig, you'll do more in radian mode. Okay, but this year we're going to do more in degree mode. Okay, so we're going to solve each equation to the nearest tenth. And then it says use the given restrictions. Okay, so we're going to solve to the nearest tenth and then use the given restrictions. So we're trying to find the sign if it's equal to 0.4 for -90 to 90. That is the restriction. Okay, so I'm going to use my green one. Okay, so -90 to 90, that is my given restriction. So what we learned yesterday is we are going to do the sine inverse in order to solve for theta. So if you know that the sine of theta is equal to 0.4, to find theta, we do the sine inverse of both sides. You do need to put this on the left side. Okay, so theta is equal to the sine inverse of 0.4. Okay, so we're going to go ahead and find that in our calculator. Okay, so make sure your mode is still in degrees. We're going to do the inverse tangent of 0.4. Okay, and then we can go ahead and round that to the nearest tenth, 23.6 degrees. Okay. When you did that, when you solved for theta, did you get a solution that was in the restrictions? So is this within -90 to 90? Yes. Okay, so this is going to be your answer. If it is already in the restrictions, it is very straightforward. Okay, so when you're trying to find something that's -90 to 90, you may remember this from the other day. If you're going from -90 to 90, you're in quadrants 1 and 4. Okay, quadrants 1 and 4 are the restrictions for the capital sign. Okay, so the reason why this worked out is because these are the same restrictions for the inverse of sine. Okay, so it's the capital sign. Okay, and then sometimes they'll put like of A. All right, so when you do the inverse, if it's in those restrictions, you don't have to do anything else. Okay, why don't we have to do anything else?
because they're the same restrictions for that capital sign. All right, and then we're going to look at part B. So you're going to see part B is very similar. You have the same equation. You have the sine of theta equals 0.4, but your restrictions are different. So if your restriction, okay, is not the same as the inverse, we're going to have to do another step. So if we didn't do part A first, okay, we would be doing the sine inverse of 0.4. We just did this, so we know that it's 23.6 degrees. Okay, and 23.6 degrees is not between 90 and 270. Okay, if you think about where that is on your unit circle, if you're going from 90 to 270, that's going to be which quadrants? Yep, 2 and 3. Quadrant 2 or quadrant 3. Okay, so if theta is not between those restrictions, so in this case between 90 and 270, then you go to step 2. Okay, so sometimes this is a one-step problem, sometimes it's a two-step. It just depends on what theta has to be between. Okay, so since theta is not in the given restrictions, we have to use that 23.6 degrees as a reference angle. Because just like with those special points we've been working with, even if it's not an exact value, one of those special places, you still have reference angles, and we can determine what quadrant to place the reference angle based on those restrictions. Okay, so in the restrictions, it's either quadrant 2 or it's quadrant 3. Okay, we know that because it says it's from 90 degrees to 270, so we know it has to be somewhere on this part of the circle. We also know that according to All Students Take Classes, that the sign is positive in quadrant 2, and in quadrant 3, the sign is negative. So let's look at the equation that we're given. Okay, we are given that the sign is equal to 0.4, which is positive. Okay, the 0.4 is positive. Okay, I'm going to give you a second to write that down and to absorb that. Okay, so we know it's between 90 and 270. We're given that the sign is 0.4, which is a positive value. So in quadrant 2, sign is positive, and quadrant 3, sign is negative. So I know that this has to be in quadrant 2. Okay, so our solution has to be in quadrant 2. That's where the sign is going to be positive. So that's where we have to draw our reference angle. Okay, so we're going to draw the reference angle in quadrant 2. Okay, and this is our first time doing this, so it's okay if we're trying to put the pieces together still. Okay, we're going to do this several times. So if I draw the reference angle in quadrant 2, my reference angle is the 23.6 degrees. Okay, you can just go ahead and estimate that Well, that's kind of a large estimate, but it's okay. Okay, so this is 23.6 degrees. That's my reference angle. Okay, so once you know what quadrant it's in, you're going to draw the reference angle in quadrant 2. What you have to figure out is the value of theta that starts at the terminal side and ends where your reference angle is. So what you have to figure out is this angle. Starts at the initial side, ends here. Okay, do we have any ideas on how we can find out what that value of theta is? Subtraction from what? 180. Great. So it's just 180 minus 23.6. Okay, and this is a calculator problem, so you can use your calculators to find that. Okay, so your solution is 156 degrees, 0.4. Okay, so really quick, I'm just gonna do a very brief explanation on how this is working, hopefully based on some values that you already know. Okay, you don't have to draw this. Okay, we've been working a lot with certain values, okay? So I feel like we're pretty good at this. Are you guys with me that the point at pi over 4 is root 2 over 2 and root 2 over 2? Yes? Okay. So if I told you that the sine of theta was equal to root 2 over 2, what would the value of theta be? Okay, so it could be pi over 4. And then if I gave you a restriction that it couldn't be in quadrant 1, remember you could use the all students take classes. It would be in quadrant 2 here. Okay, and what it is it's the same reference angle. This is a negative root 2 over 2, positive root 2 over 2. But there's 2 places on the unit circle where this is going to be your coordinate. Okay, following that logic, there are 2 places on the unit circle where the sign is 0.4. One of those places is the 23.6. It's in quadrant 1. Okay, the other place is in quadrant 2, just like here. Quadrant 1 has a sign value that's root 2 over 2. Quadrant 2 has a sign value that's root 2 over 2. Okay, so that's why there are 2 places. Okay, we're used to seeing those 2 places, so we have to find the second place is what we're doing there. All right, so we're going to try this again with part C and part D. Notice for part C and part D, I gave you the same equations again so you guys can see the difference between these. So in part C, we have to find the theta value between negative 90 and 90. So all we have to do to start is theta is equal to the tangent inverse of negative 2. Okay, and I want you to go ahead and calculate that. Okay, so when you do your tangent inverse of negative 2, you're going to get negative 63.4 degrees. Is that between negative 90 and 90? Yes, so then you would be done. That is all you would have to do for that problem. Inverse, if it's in the restrictions, great. Okay, now that happened again because negative 90 to 90 is going to be where your capital tangent inverse was restricted. Okay, so anytime you do this, you are not going to have to go to step 2 if it matches the restrictions for those inverses. So if the restrictions match the capital sine inverse, the capital cosine inverse, or the capital tangent inverse, okay, then you are not going to have to go on to step 2. Okay, for sine, it's negative 90 to 90. For tangent, negative 90 to 90. They just don't include it for tangent. Do you guys remember why? What happens at 90 degrees for the tangent? It's undefined. Okay, and then for the cosine, it is from 0 to 180. Okay, so if it matches those, you'll just have that one step. Okay, now for this one, we know it's not going to match because the restrictions are different. Here it was negative 90 to 90. Here it's 180 to 360. Okay, so if you didn't have part C, you would be doing what we did for part C. Okay, and it's not in the restriction. So if it's not in the given restriction, we have to use the what? So we use the, say it again, a reference angle. Okay, so we're going to use the reference angle, which in this case, what is the reference angle of negative 63.4? Because reference angles are never what? They're never negative, okay? So in this case, our reference angle is the positive 63.4 degrees. Okay, so we're going to use 63.4 as a reference angle. We have to decide what quadrant we're going to draw it in. All right, well, this is 180 to 360. So 180 to 360 is either quadrant 3 or quadrant 4. So I'm thinking of my all students take classes. Okay, so this is Q3 or Q4. Okay, I'm going to give you some moments of silence, and I just want you to think about, is this going to be quadrant 3 or quadrant 4? Can I figure this out without just guessing? Do I know how to determine which quadrant it is? Okay, how many of you think you know what quadrant it is? Give me a thumbs up if you do. How many of you with your thumbs up think you could tell me why it's quadrant 4? Okay, Rocco, tell us what you're thinking. Okay, so it's based on that logic. So with the tangent is always positive in quadrant 3. And in this equation, you have the tangent is equal to what? What's the tangent of theta equal to? Negative 2. So your logic is right. Okay, in quadrant 3, the tangent is positive. But we're given that the tangent is what? Negative. So we want to find where the tangent is negative, which means it's going to be in what quadrant? Yep, great. And if it was positive, yes, you would choose 3. Okay, so it's in quadrant 4 because your tangent is negative. Okay, this means that's where it's positive. Okay, all right, what questions do you guys have for me on how to figure out which one it is? So it's based on this equation. So if this is equal to a negative, choose the one where it's not positive. All right, now we get to draw it. Okay, so in quadrant 4, you draw the reference angle. So you are drawing the angle 63.4 degrees. Okay, so you draw that terminal side of your reference angle. Okay, this is 63.4 degrees. If that is your reference angle, do you guys think you could draw for me with an arrow what angle you're trying to find? Okay, so we always start at the initial side, and then it's going to go all the way around here. Okay, so how can I figure out what this angle is here that I just drew? Subtract from 360. Great. Okay, so now I can do 360 minus 63.4. And my theta value is 296.6 degrees. And see how that's going to fit in between those restrictions? Yes. Okay, so we're gonna try this one more time, and then I'm gonna let you practice on your own. Okay, so we have the cosine of negative 0.778 for 180 to 270. Okay, so I want you to do the first step. Okay, so finish up that first step, and then I want you to start thinking about the second one. All right, so Carson, what did you do first here? That, not the negative, but what do you really mean? Yeah, great. Do the inverse cosine of? Nice. Okay, and then what did you get for that? Great, 141.1 degrees. Okay, does anybody have questions on that first step? Doing your inverse. All right, and then this one is a little bit trickier. Okay, it's not in the restriction, but in this case, we need a reference angle. Why can't my reference angle be 141.1 degrees? It's greater than 90. It has to be acute, right? Okay, so let's write this down and then we'll problem solve together, okay? Because you will have a couple that are like this. So it's not a reference angle because it's greater than 90 degrees. So we're going to draw this one a little bit differently. We know that our theta has to be in which quadrant? 3. That was the only restriction they gave us, right? 180 to 270. So it has to be in quadrant 3. Okay. So that means we need the terminal side in quadrant 3. So this is just going to affect the way that we're going to draw it. Okay, so it's not a reference angle because 141.1, that's greater than 90. But we do know that that theta for our reference angle has to be, or that our theta has to be in quadrant 3. So we need the terminal side of our reference angle to end up in quadrant 3. Okay, so in order for that to happen, okay, we are going to start from here to draw our reference angle in quadrant 3. Okay, so for our reference angle, if I'm going to go 141.1 degrees, if I want to end up in quadrant 3, okay, I'm going to be a little bit past the 135 degrees. We're going to draw our reference angle like this. Okay, so this is 141.1 degrees. Okay, so we want it to end in quadrant 3. That's why we're going this direction, because if we did 141.1 in the other direction, we'd be in quadrant 2. Now the theta value that we have to find starts at the initial value, ends at the terminal side. Okay, so I'll say that setup part one more time. So if you have something that's greater than 90 degrees, okay, wherever you want it to end up, you are going to start the initial side here, okay, and then it is going to end in that quadrant. Okay, so the 141, I can't start it here because it would end up in quadrant 4. So instead, I reverse it. Okay, and I can see that the top half of this here is going to be 180. So I could either find this little angle and add it to 180, or is there another way that we can find that angle? Do you guys see that together these make one circle? And one circle is how many degrees? Yep. So it's 360 minus 141.1. Okay, that's your value for theta. Okay, there are some cases where when you end up in quadrant 3, okay, instead of knowing this angle, if you know that this angle is 38.9 degrees, you could take 180 and you could add that angle together. But that would only be if you don't know this. Okay, and this one, we knew this one, so this was quicker. But you could also say, oh, hey, this is the top half of the circle. I could just add it to that. All right, so today you're going to finish your 11.7, your day 2 worksheet. Your worksheet, okay, you might not have all of your room to write it here, so you can put your work on a separate sheet. You need to have work for every single one of these. At the very least, okay, for number 12, your work should look like theta equals the tangent inverse of 1.4, and then you can write it there. If there's another step, I want to see the reference angle. Okay, if you feel like you have room on here to do that, fine. If you like a little more space, you can put that on another sheet. Okay, and then even for like this multiple choice question, I need to see your work. So all of these need to have some amount of work shown, okay, not just the solution.